Example 2.14. A book with many printing errors contains four different formulas for the displacement y of a particle undergoing a certain periodic motion. A. Y equal to A sine 2 pi t by t. B. Y equal to A sine Vt. C. Y equal to A by capital T sine t by small a. D. Y equal to A root 2 sine 2 pi t by capital T plus cos 2 pi t by capital T, where A, that is equal to maximum displacement of a particle, V equal to speed of the particle, capital T equal to time period of motion. Rule out the wrong formulas on dimensional grounds. Now see, first we take the first formula y equal to A sine 2 pi t by capital T. Now here one thing you have to remember always, the trigonometric functions sine, cosine or tangent operates on angle, and angle is dimensionless. It implies that whatever the term is given to you with any trigonometric function, here say 2 pi t by capital T. So whichever is the term given to you, for that always the dimensions should be m0, l0, t0. So whenever any trigonometric function appear in the equation, first check the dimensions of that particular term associated with that trigonometric function. Here 2 pi t by capital T is given to you. So 2 pi, that is constant, it is dimensionless. Small t, that is time, so dimension, that is t raised to 1. Capital T, that is time period, after all it is time, so t raised to 1. So finally you will get m0, l0, t0. So here this particular function is now clear. It is with dimension m0, l0, t0. Then for a and y. Now if dimensions of sine 2 pi t by capital T, that is m0, l0, t0, it implies that now easily you can understand, if the dimensions of y and a both are same, then and then only your equation will be dimensionally valid. Now y, that is what? Y, that is displacement. So its dimension, that is L1. And see here, A, that is maximum displacement. After all, it is displacement. So for that also the dimension is L1. It implies that. Now dimensions of left hand side and dimensions of right hand side, that is same one. So we can say equation is dimensionally valid. Clear? Now, second equation. Y equal to A sine Vt. We discussed for this function sine Vt, the dimensions of Vt, that should be m0, l0, t0. So first of all we have to check it. Dimensions of v into t. So dimensions of v, that is velocity, so that is L1 t minus 1 into time t, so dimension, that is t1. So finally you are getting the dimensions, that is L1. So it is not equal to m0, l0, t0. It implies that we can directly say this thing, equation is dimensionally not valid. No need to check the further thing. Clear to all of you? Then after third equation, y equal to a by capital T sine small t by a. So first we have to check the dimensions of small t by a. So dimensions of small t by a, that is equal to, now t that is time, so t raised to 1. A, that is maximum displacement, so after all it is displacement, so that is L raised to 1. So finally you are getting m0 L minus 1 t raised to plus 1. And that is not equal to m0 L0 t0, and therefore equation is dimensionally not valid. Now fourth equation, y equal to a root 2 into bracket sine 2 pi t upon capital T plus cos 2 pi t upon capital T. Here with sine and cosine both, the term that is 2 pi t by t. So first check the dimensions of it. It should be m0 L0 t0. Let's check this thing. So 2 pi small t upon capital T small t time. So t raised to 1 capital T, that is also time. So t raised to 1. So resultantly you are getting m0 L0 t0.
Dimensionless.
Now y, that is displacement. So for that L raised to 1. For A, that is maximum displacement, again L raised to 1. So resultantly the dimensions of left hand side and dimensions of right hand side, that is same one. So equation is dimensionally valid. Clear?